Hi everyone. Today what we're going to do is we're going to work through a means to be able to graph lines very quickly. And so we're going to kind of move away from that old process for us, which is referring to like maybe our fallback. If all else fails, a table of values. That we need to be a little bit better with that. And so since that last section, we hopefully got pretty comfortable using a table of values. What we want to do now is we want to be quicker. We want to be more efficient with being able to graph a line. And so what we're going to do then is we're going to address graphing by a method called slope intercept. Now, to start off with that, we need to be able to work our way through that table of values again very quickly. So what you see in problem 1 is I want you to graph those lines using 3 points. Okay, we should all be able to recognize that each one of those equations are all lines because we notice that the exponent on both the x and the y are 1s when y is isolated. Now, if we have to graph then a line, my recommendation to you would be don't use 2 points. Yes, 2 points is the minimal number of points that are needed to be able to graph a line. However, if we make a mistake on either one of those points, our line's going to be incorrect. That is, we shouldn't make mistakes on that. So, what I want you to do is I'd like you to set up dealing with question 1 the way I have on the screen. Now, you don't need to match my colors. That's just going to help us to be able to tell which graph gave us which which equation gave us which table, which produced which graph. But we're going to do small little table of values. So I'm going to walk through the red one first. And so as I work through that graph, that relation y equals 2x plus 1, as I said, the table of values should be pretty smooth for us by now. So maybe what I do is I select a negative value, my easiest number to sub in, and maybe an easy positive number. Now, this is what I want to make sure that we're good with on my reasoning for 3 points. Let's just say that I did 2 points, and maybe I chose like a negative value, and then maybe I chose 0, easy value. Okay, well, when I go ahead and I plug in -2 into my graph wherever I see my x, well, then I have 2 times -2, that's a -4. I then add on 1 to that, that's a -5. If I sub 0 in, then that's going to give me 1. I would then go through and I would plot the point at -2, -5, 0, 1, and I would connect those and extend it the width of my grid, arrows on the end, and I go, perfect. I'll label that with my equation number 1. Nice. And I have no idea whether that line's correct or not. By me using 2 points, yes, that is the least number of points that are required to produce a line. But by only using 2, if I make a silly calculation error in there somewhere, I will never know if I'm correct. And some of you should have spotted my silly calculation error. What the heck is that? So let's just say that we follow the recommendation in the problem, and I'm going to find a third point. So let's say that I sub in an x value of 3. Well, if I sub in an x value of 3, 2 times 3 gives me 6, add on 1 gives me 7. That means that that line needs to pass through the point 3, 1, 2, 3, 4, 5, 6, 7. I am right at the top. And notice, my graph doesn't go through that point. But I know for certain that my equation is a line because it follows my kind of rules with my exponents. Okay, so now I find my mistake. And then I look back at my table and I say, oh, wait a second. 2 times -2 is a -4. And if I add 1 on to that, oh, that shouldn't have been a -5. That should have been a -3. I now find my mistake. I should have been at -2, -3. And now when I connect those, all of those line up to get, I found my mistake. So I don't think finding a third point in our process is that cumbersome that when you take a look at that, you go, oh, that's going to slow me down so much. I don't think so. So my argument to you then is find a third point. You might make one calculation error. We're all human. We're going to do it. But the chances of you making two within the same table, I think that's pretty slim. You'll find your mistake and you'll make sure that you have the correct line. So let's go super fast. -2, -3, 0, 1, 3, 7. And now I can connect those using my straight edge. Be as accurate as you can be. It's a little tough on the iPad. As you can tell, all of a sudden stuff starts moving. And it's still moving. And when I connect all of those and extend it the width of the grid, now I'm in purple. I have no idea why that's purple. Eventually I'll get this right, guys. We get something like that. We now label that with our equation number, and we're good. Okay, what I would like you to do then is I would like you to go through and graph the next three of those lines, all by using a table of values. 3 points per equation, and I think we should be good. So pause the video now. Okay, we're back. So I'm going to go pretty quickly. As I said, this should be pretty comfortable for us. Maybe I pick a -1, I pick 0, and I pick 2. Those are nice, easy numbers to work with. Y equals -x. So if I replace my x with -1, then I have the negative of -1. That's a positive 1. Sub in 0, I get 0. Sub in 2, I get -2. Plot my points. -1, 1. 0, 0. 2, -2. I get a little confirmation that those, yes, all line up. And so when I connect those and extend it the width of my grid, yikes, this is difficult. Your graphs are all going to look so much better than mine. We get something like that. And there's my graph 2. Okay, my graph 3 was y equals 3x. Well, maybe I really like those x values. Sub in. Plot your points. -1, -3. 0, 0. 2, 6. Yep, they all line up. Connect them. That one was a little better. And our last one, our blue relation. So if I like those numbers, then if I replace my x with -1, I have -2 times -1, which is a +2. That's going to get me to 6. Sub in a 0 is nice. If I sub in 2, then -2 times 2 is -4 plus 4 gives me 0. Plot my points at -1, 6. At 0, 4, and at 2, 0. And now I connect those. And again, hopefully yours is looking a little nicer than mine. You're not doing it on an iPad. At least I hope not. Okay, that is so out of whack, that blue one. Sorry, I can't live with that. I need to take my time and make sure. And trying not to select anything on the iPad is a little difficult, but maybe I get something like that. And there's my graph 4. Okay, hopefully your picture matches up with mine. Now let's jump in and see where we go at the bottom of the page. So what I want you to do is I want you to now take a look at your graph and look at the table that's been provided. And I just put in a little blurb there that we're going to examine the equations of the graphs, lines, and their graphs. And what we want to do is we want to see if we can find the properties for each graph within the equation. So we're going to complete that chart. using the lines above. So we're going to use the graph. So what I want to do is I just want to go through the first one together, and then I'll leave you guys with the rest. So when you take a look at that chart then, what we need to do is we need to try to find both components that the chart speaks to, the slope and the y-intercept of each line. Okay, so we need the slope and the y-intercept. Well, the slope we should all be automatic with. That we're rolling over in the middle of the night saying rise over run. The y-intercept is going to be something that's going to be new to us. When we talk about the y-intercept, what we're talking about is where the y-axis intersects our curve, or vice versa, where our line hits the y-axis. So when you hear the word intercept, quite often we'll think of intersect. Like they sound pretty familiar, similar. And so really what we're looking at then is where we intersect with the y-axis. Okay, those are the two properties we're looking for. Let's take a peek back at the graphs. So there's my big ugly mess. And I know you guys love that big ugly mess on there. What I'm going to do is I'm going to focus in on the first graph. So we're going to zero in on that red graph. Now, what I want to do is I want to make sure that we're examining this curve, that equation with the picture on the graph. So what I'm going to do is I'm going to use some purple, so I'm going to mark up that graph a little bit. The first thing I have to find is my slope. And so to find my slope, I need to figure out how I move from point to point on that line. So maybe what I do is I go through and I actually use the points in my table. So maybe I select this first red point. And what I'm going to do then is I'm going to select another red point, like maybe that one. I know the location of those points. And what I'm going to do now is I'm going to figure out the slope as I move from point to point. So I'll notice that I go across 2 and I will go up 4. And so I know that my slope is rise over run. And when I simplify, I get a slope of 2. Nice. Okay, I also know my y-intercept. Because when I zero in, where does my red line hit my y-axis? It hits it right here. So my y-intercept is 1. It's not 0, 1. We don't list both coordinates. We list the value on the y-axis. And if we found that then we should be able to jump back into that chart to complete that chart. And so what we just found then was for that red graph, we found that it had a slope of 2 and a y-intercept of 1. Okay, what I want you to do now is to take a look at your graph, and I want you to fill in the next 3 rows. Okay, the next 3 rows. Okay, pause the video now. Okay, and if we're back, then hopefully we have this as confirmation, that we had a slope of -1 and a y-intercept of 0. We passed through the origin. Oops. We then had a slope of 3 and a y-intercept of 0. We passed through the origin again. And in the last one, we had a slope of -2 and a y-intercept at 4. Okay, hopefully those match up. If they don't, then let's take a look back up at the graph and see if we can find our mistake. Now what I'd like us to do is I'd like us to try to predict. That is, what we see in the graph. My equation looks like this. That was the slope and the y-intercept. My equation looks like this. That was the slope and the y-intercept. Looks like this. That was the slope. Looks like this. That was the slope. And so, if my slope looks like, my equation looks like this, could you predict your slope and your y-intercept? Okay, I want you to pause it now and try to fill that in. Okay, hopefully we're back. We feel pretty confident with it, and we were able to say, my slope is m and my y-intercept is b. And if we did, then we're doing pretty well. That we can actually identify that the slope is the coefficient on my x when my equation is written in the form y equals. And my y-intercept is the constant in that equation when my equation is written in the form y equals. So if we were able to come up with that pattern, I think we're doing great. Now what I want to do is I want to jump in and start using this stuff a little bit. So let's take a peek and see if we can go backwards in a way. Take a look at the grid on the top of that page. I have given you 4 lines on that grid. And what I'd like us to do is to be able to take a picture and quickly be able to write down the equation that would give us that graph. So we're working backwards from what we generally go through. Okay, let's walk through the first one together. Now, I'm just going to highlight that first one in red. We are looking for the equation of line A. And so, if we know then that all equations for lines can be written in the form y equals mx plus b, where m is the slope and b is the y-intercept, then I just need those 2 properties to be able to write it. Okay, can I come up with the y-intercept for that line? Like the y-intercept is probably the easiest thing to find because we just need to see where does that line hit your y-axis. And we identify that point right there. Okay, what's the y value at that point? It's 1. Nice. Okay, now we have to figure out the slope of that line. And to figure out that slope, we're going to have to consider 2 points. So what I want to do is I want to find another point on that line where that line goes through the exact intersection of grid lines. And so maybe like I backtrack a little bit and I say, hey, that looks like it goes exactly through as well. Okay, well, let's calculate the slope. Well, that means that I went backwards 1, so I had a run of -1, and I went up 1, a rise of 1. So my slope then would be 1 over -1, rise over run, which reduces to -1. The nice part is it wouldn't have mattered what other point. Like maybe we looked all the way down here in this right corner and we said, but that was another point that I saw the line go through the exact intersection of grid lines. Well, no worries. Now we would move across 1, 2, 3, 4 units and down 4 units. So my rise would be -4, my run would be 4, and we get to the exact same slope. It never matters what points you choose as long as we can find ones that go through the exact intersection of grid lines. So now that I have all that information, I just need to plug it in its spots. So I know that my equation is going to look like y equals. My slope is the coefficient on my x, and my y-intercept is my constant, no variable. Now, I'm hoping a lot of you guys look at that and go, boo, that's horrible form. That yes, we should never be writing that coefficient of -1, but rather just our negative sign. And there you go. There's our equation. So what I'm going to do is I'm going to get rid of all of this slope and y-intercept work. And what I'd like you to do now is I'd like you to go through and come up with the equations for the next 3 lines. Okay, go to it. Pause the video now. Okay, and if you're back, I've gone through and I've just gone and color-coded each one of those lines just to draw our attention to it. So I'm going to work with those colors in each case. So line B, I have highlighted in blue. So for me to locate, I need a y-intercept. My y-intercept is at 1, so I know that I'm going to have y equals, and I'm going to have a +1 as my constant. I need to find my slope. And so maybe then I take a look. There's another point where I'm at the exact intersection of grid lines. How do I get to that? I am to the right 1 and down 2. So my slope would be -2 over 1. That's a -2, and that's my coefficient on my x. Make sure that you have that coefficient on your x, that it's not y equals -2 plus 1, but that we have that independent variable in there. Okay, now I'm going to jump and I'm going to go through graph C. Graph C is my green line. So I notice that my green line has a y-intercept at -1. Now I can go through and I can figure out my slope of my green line. Well, there is another point, and hopefully you can see those points highlighted easily. For me to figure out how to get there, I'm just going to change colors a little bit so we can see it maybe a little clearer. That I would now have to go to the right 1 and up 3 to get back onto that line somewhere. And so that's going to give me my slope of 3 over 1, which is 3, as my coefficient of my x. Again, hopefully we match up. Now, I should be able to just erase that writing. There we go. Just to clean up the picture a little bit. And now let's jump into graph D. So if we struggled a little bit through those first ones, then I want you to come up with the equation now for line D. Pause the video. Okay, we're back. So to be able to work through D, D is on my purple line. There's my y-intercept all the way down here, and a y-intercept of -4. To find another point where that lies, there would be a case, or there would be a case, or there would be a case. And if we notice, in all of those cases, I'm going over 1, up 3. Like maybe I went over 2 and up 6. But we notice that if I divide my 3 by 1 or my 6 by 2, and that I'm going to end up getting a slope of 3. So my equation is a slope of 3 and a y-intercept at -4. And there we go. So hopefully we match up with going backwards, being given a graph and being able to determine the equation of that line. Now I want to really hunker down on what is our process to graph a line. So let's take a look. I'm going to give you a second to get that down on your page. So right in that middle of the page where you see that big blank space, I'd like you to write down your y equals mx plus b form of your line. That would actually be referred to your slope-intercept form of a line. And I think you can see why it's called your slope-intercept form. Because we can read the slope and the y-intercept straight from the equation. Now, if you can take a look onto the right, I want you to jot down all that stuff on the right. So, pause the video now, make sure you get that down. Okay, and we're back. So, when you take a look then at that steps or those words on the right, that is our two-step process for being able to graph a line. I'm not kidding when I say I want you to be able to graph a line in about 15 to 20 seconds. No more table of values, that's really slow. We should be able to graph a line in about 15 to 20 seconds using this method. So, what's the first step? First step, plot your y-intercept. We want a point on our line. Well, now we need to create the line, which means we need other points. And so what we're going to do is we're going to plot the other points that would exist on that line, moving according to slope. Okay? It might seem a little confusing right now. Honestly, we're going to look at it and we're going to say that's the most direct way to graph a line. So let's actually jump in and start graphing. Okay, let's take a look at A. I've given you the equation y equals 2x minus 1. And no joke, I want you to be able to graph that in 15 to 20 seconds. So for us to do that, let's just highlight a couple things. First off, we should be able to recognize that our slope is 2. And so universally, you'll see the symbol m used to refer to slope. We also then can recognize that our y-intercept is at -1. Universally, that b value would be used to represent the y-intercept of a line. So I'm going to follow my step-by-step process. Step 1, plot the y-intercept. So on my y-axis, put a point at -1. Now I have 1 point on that line. Now I need other points. Well, now my slope says that it needs to have a slope of 2. And if we really drill in that slope is rise over run, then I need a fraction that would represent 2. And so the easiest thing to do for most people, even though it would be like a total boo situation, is like we could make it 2 over 1. So for us to move according to a slope of 2, we would need to go over 1 and up 2. That tells you, put another point there. And then we would have to go over 1, up 2. Put another point there. And we could continue that. Like perhaps we even go backwards 1, down 2. So I just did 2 negative movements together, which would give me a positive. And we could keep doing that if we wanted to. We don't need that many points though. Once we get a couple down, then we can connect them all. A couple points allows us to be relatively accurate with our line, and we need accuracy. Now I connect them all, extend it the width of my grid, arrows on the end, and we're good. So the key thing is you guys look at that and go, that was not 20 seconds. But you're not going to be doing any of the blabbing I'm doing while you're graphing that line. You're not going to draw on all those little movement arrows for rise and run. You're going to plot the y-intercept, and then you're going to move according to slope. Okay, let's take a look at B. What you see in B would have been an equation that would have been a real pain for us to build a table for. That yes, we go through and pick multiples of 3 for our x values, but we don't even have to worry about that. And in fact, most people are going to like having a fraction slope. So what do we have? We have a slope of -2/3. Notice what I did when I wrote that down. I wrote my negative on the top value. I would recommend that for most people. Not needed. We notice our 4 is our y-intercept. Okay, here we go. Plot your y-intercept. Now move according to slope. Well, notice that my slope, when it's in fraction form, actually gives me my rise and my run. So I need to move according to a rise of -2, so go down 2, and a run of 3, so go to the right 3. There's my new point. Okay, let me get rid of all those arrows, because we can just count squares over to there, or count units over to there, and we're good. There would be an instance. Okay, I just want to show you, though, that you could have done something different with your slope, that we could have viewed that slope as 2 over -3 and put the negative on the bottom. We should be good that the blue slope is the same value as the green slope. It's just that the green slope's in bad form. But notice, we're still good to get our other point. Now go up 2 and over 3. I have to go backwards because my run would now be negative. Okay, I don't have to draw those arrows anymore. And instead, we can just move according to units. And notice that those 3 points all line up. Let's connect them. extend it the width of the grid, yikes, that was really off the grid. And there we go. Now, can I just get you to take one more look and just confirm something? Look at the slope on the given line. Notice it's negative. We have a little confirmation that my purple graph has a negative slope because it falls to the right. Okay, I want to show you what the real common mistake would be here. And it means that we're going to make a mistake when we interpret slope. That notice the way that that's written is you have a slope of 2/3 and your negative is right on your fraction line. Well, we need to put that negative somewhere. And so in the blue, we put it on top, or in the green, we put it on the bottom. The most common mistake is I have somebody who thinks of it that way. Now, are we all good that to calculate that orange fraction, you would have a negative divided by a negative, that would give you a positive? And so therefore it wouldn't have the correct value of slope? But what would end up happening is we would start at that y-intercept and now move according to slope. We go backwards 3 and down 2, and we would then connect that to form our line. And can I just get you to look at that orange line and recognize that that's actually a positive slope? Because it's rising to the right. So a real common mistake is that when you see that slope, or sorry, that negative put right along your fraction line, we apply it to both the top and the bottom. We got to stop ourselves. If I make both of them negative, then my fraction's really positive. So apply it to the top or the bottom, and you're good. Okay, I think we should be pretty good in that occasion. I'm just going to get rid of that incorrect orange line so that we've got something to match up with. Okay, let's take a look at the last two. Okay, I want you to take a look at C, and I want you to notice one big thing, that we cannot read our slope and our y-intercept from the equation. Okay, I want you to take a look at C and notice that that equation is not written in slope-intercept form. It's written almost in what we would refer to as standard form, with my variables together on one side of the equal sign. So for me to write this in slope-intercept form, then what I'm going to do is I'm going to get my y all by itself. So maybe what that means is I need to get rid of that 3x. So I'm going to go through and I am then going to get rid of a positive 3x, which means I subtract 3x. The 8 was already on that side. I still have my plus 8. Okay, notice my coefficient on my y. It was negative. I didn't drop off that negative. Now what I can do is to get rid of that y, which means I have to divide out my coefficient. So I'm going to divide both terms on the opposite side by -2. Okay, I can do a little cleaning up. Take a look at that first fraction. Your first fraction is a -3 divided by -2. Now, we can't divide 3 by 2 evenly, but I can simplify a negative divided by a negative. That's going to give me a positive amount. Now, take a look at the last fraction. We have a positive 8 divided by a -2. And if I was to take a positive divided by a negative, then I'm going to get a negative, and 8 divided by 2 gives me 4. There would be how I could isolate and write my equation in slope-intercept, because we can now see there's our slope and there's our y-intercept. Okay, what I want you to do is I want you to go through and use this one as a bit of a check. I want you to try to graph that line, y equals 3 halves x minus 4, using slope-intercept, and let's see how fast we can do it. As I told you, on like a test day, an evaluation day, I would expect you to be able to graph this in like 20 seconds. So let's give it a go. Pause the video now. Okay, we're back. So to go through then, I would have a y-intercept at -4. Now I have to move according to a slope of 3 halves. So that means that I have a run of 2 and a rise of 3. There would be my next point. I can get rid of all that stuff because I can just move according to units, over 2 up 3, over 2 up 3. Maybe that's enough points for me. I connect them and extend that the full width of the grid, and there we go. So hopefully we match up and we've got a decent sketch, decent graph. Now, if we're good with that process, then I want to go back for a second. And I actually want to show you guys maybe a better way to think about isolating that y. Because I need to tell you that if I was ever to tackle that problem, I would not have done it that way. I want you to notice your first line. It's too easy to miss that negative. Common mistake. I want you to look at the next line. It's a pain to divide out by a negative value. Now I have to remember to change the signs of everything. Oh, that's such a pain. Common risk for mistake. I want you to look now down at the equation I gave you. When I look at that equation, I notice that if I want to get my y all by itself, I'm going to put a little focus on what sign my y is. And if you notice, your y is already negative. So I really want my y to be positive. Notice that when you went through and solved that equation, your y is positive. It's all by itself. So by putting a little bit of thought as to what sign your y is, then let's picture this y term over on the right side. We should be good that to get rid of a minus 2y, you would have to add 2y. But while I'm doing that, I don't want to have the y term on the same side with the 8. So let's think about the 8 then being on the left side. So to get rid of a plus 8, I'm going to minus 8. Now what I can do is I can write that as y equals by getting rid of that times by 2. So what I'm going to do now is I'm going to take that 2 and I'm going to divide it out from both terms on the left side. Okay, can I divide 3 by 2 evenly? Nope. So leave it as a fraction. Can I divide -8 by 2 evenly? Yes. And what you see in purple is, I think, the best or most efficient way to consider isolating your y. Okay, if you like that, then I would run with that. Let's use D as a little bit of a gauge. Now, we're going to have a little quirk that pops up in D, but that's okay. I want us to try to go start to finish on D. So you're going to go through. You notice that your equation is not in slope-intercept form. So I want you to isolate your y, graph your line. I would say that I think we should get through this whole process in about a minute. Okay, so I want you to pause the video now and give it a shot. Yeah, okay, and so we're back. And so if we were to work through, I'm just going to do this in blue, that if we were to take that equation, I think in this case, because I see that my y term's positive, I'm going to try to then get rid of my x term. That then is going to mean that if I divide out my 3, I can't divide my 3 out of 4 evenly, so that stays as a fraction. But I can divide my 3 out, and we simplify. So we get to that case. Hopefully we match up. And now we're able to identify slope and identify y-intercept. You never need to show me that. We should then be able to go through, plot your y-intercept, and move according to slope. I have a run of 3 and a rise of -4, and that gives me my second spot. Or we maybe had it backwards and we said that I have a run of -3 and therefore a rise of +4. Any way you want to come in on that, you're good. Okay, now we can go through, connect those points, extend your graph, the width of the grid, arrows on the end, and we are good. So, hopefully we were able to match up with that. And we were able to go through pretty quickly. As I said, come test day, if we're able to graph a line in 20 seconds, if we're able to rearrange the line like we did in blue in 20 seconds, then I think we're working at a pretty good pace. Okay, your job now, jump in and get as much practice as you can to make that graphing method as automatic as possible. Okay, good luck.